Yes, class. In the last class, we couldn't complete this portion. So let us just complete this now. So see, we had stopped till this point. Let us just complete this. So see, LHS and RHS both are ready. So let us equate the masses. Mass is 0 here. Here we have minus y plus z. So equation is minus y plus z is equal to 0. That is y is equal to z. Come to length. L to the power 1 we have. This is L to the power x plus 3y plus 2z. So x plus 3y plus 2z is equal to 1. Lastly, we have time. This is t to the power minus x minus 2y minus z. So it means minus x minus 2y minus z. This is equal to 0. Fine. So what you can do, you can replace y here. Right? If y is equal to z, you can replace y here. So your y would be, see, this would become x plus 3y plus 2y is equal to 1. This is x plus 5y is equal to 1. This is minus x minus 2y minus y. I'm replacing z with y because both are equal to 0. So this is minus x. This becomes minus 3y, right? This is minus 3y is equal to 0. So x is equal to 3y from here. So this becomes x is equal to 3y. So 3y plus 5y. Or instead, let's just use the substitution method. That is better. All right, take 2 minutes then. Let me know x, y, and z if you can solve. Fine, then I'll discuss it. All right, write it. So these are the equation. Fine, equation I'll show you. Tell me, yes, tell me what are these values. Fine, take 2 minutes. Okay, I'll discuss. Take 2 minutes. Fine, class, let us now discuss. Yes, I was saying instead of just substitution method, let us just quickly simply use the equations and cancel things out, right? Let's keep z only so that we can just directly, instead of substitution, let us just use this. So we have, what do we have? X plus 3y plus 2z is equal to 1. X minus 2y minus z is equal to 0. So if we have this x plus 3y plus 2z is equal to 1 and minus x minus 2y minus z is equal to 0. So let's just add these equations so that this gets cancelled. This is y, 2 minus z is z, plus z, and this is equal to 1. So we have one equation is y plus z is equal to 1. One more equation we had, class. This minus y plus z is equal to 0. Minus y plus z is equal to 0. So let's add this. So this is 2z is equal to 1. So z is equal to half. So directly we have the answer. Z is equal to half. And we know z is equal to y. So our y will also be equal to half. If z is equal to half, so y would be equal to half. Just one x is left. Quickly, let us solve. Today I'll start the second portion also, second chapter also. See, this is minus x minus 2. Instead of y, and now I can write half, right? In this equation, I'm substituting. And minus half is equal to 0. 2 would be cancelled. So this would be minus x minus 2 minus. So 4 minus 1, 3. Minus 3 by 2 is equal to 0. X is equal to minus 3 by 2. So these are the values of x, y, and z. You can substitute it for this. Write it quickly. Let me now just cover the last portion that is left so that we can start with the next chapter. Write it. Final formula you're asking. See, final formula would be the same. Just substitute the values instead of x, y, and z. Your final equation, this is k. Now see, x is to the power minus 3 by 2. G is to the power half. And h is to the power half. So this would be the formula. Now, class, the next topic that we have is conversion of unit. This is the last. See, the first part that we had was just writing of the dimensional formula. Now what we have is the checking the accuracy of the formula. Last topic that is left is conversion of one unit of system into another system of unit. So see, in conversion of units, we have to convert 1 Newton into dyne. So we have 1 Newton into how many dynes? This is what we have, 1 Newton into how many dynes? Now see class, we have just one basic formula. With that formula, you will be able to write everything. Just remember, this number is your N1, number 1. This is your unit 1. Fine. This unknown number would be your N2. Clear? And last one would be your U2. Fine. One system of number into one system of unit is equal to number of the second system multiplied to second system of unit. Here we have the SI system present. Here we have the CGS system present. Look, our formula would be N1 U1 is equal to N2 U2. Fine. N1 U1 is equal to N2 U2. Now, how will you use it? Now the application part. What is N1 here? N1 is 1. Now Newton. How do we write the dimensional formula of Newton? You have already studied. We write it as the dimensional formula of force. Because Newton is what? Newton is basically the force only. So how do we write force? M L T to the power minus 2. 1, 1, 1, because we are talking about the first system of unit. Fine. Second system, N2 is unknown, which we have to calculate. See class, there are other methods also by which you can calculate, but here the issue is that we have to specifically use dimensional analysis. That's why we are using this method. Otherwise, there are lots of methods by which you can solve. Fine. N2. Second system of unit, dyne, that is MLT to the power minus 2, 2, 2. Fine class. Now, we want to find out this N2. This is our task. All right. This is our task. We have to find out this N2. So how do you find out this? You just divide these two. You have to bring this term into the denominator. That's the only way by which you can calculate. So mass 1 divided by mass 2 to the power. What are the powers of masses here? 1. L1 divided by L2. What are the powers of length here? 1. T1 divided by T2 to the power minus 2, because the power here is minus 2. Tell me class, is it clear till this step to all of you? Faiz, Ali, Alina? Clear?
Yes, ma'am.
Oh, good. Now see, what we'll do in the first system of unit, we have to write down the actual number. See, M1 was what? First system of unit was the SI system class, right? SI system. So what we'll do, M1, L1, T1, these are the first system of unit. So what we will do, we will write their actual values. 1 kg is the mass in the SI system, divided by 1 gram in the CGS system. Length, 1 meter. L2 in CGS, it is 1 centimeters. T1, 1 seconds by 1 seconds to the power minus 2. This will be cancelled. 1 second divided by 1 second would get cancelled. Now class, look. Just wait. Now what we'll do? we will write 1 kg or 1 gram. We have to convert it into one of the units so that we can get it cancelled. So what we can do, see, 1 kg is there. So we can write this as 1000 gram. Just a second, class. Give me a second. Yes, class. So what we can do? What do we have? We have 1 kg present, right? So we can write 1 kg as 1000 gram divided by 1 gram. Then we have 1 meters. 1 meters, we can write this as 100 centimeters divided by 1 centimeters. And this was already cancelled. Now see, gram got cancelled, centimeter got cancelled. So what is N2? N2 is equal to 1000 into 100. That is 10 to the power 5. So you can say 1 Newton is equal to, what is N2? 10 to the power 5 dyne. Tell me, class, this is clear to you at any step, any confusion to anyone? Alina, Faiz, Ali Muhammad, Ali, Ali Muhammad, is it clear to you?
Yes, ma'am.
Yes, ma'am.
Write it down then. See class, one more example we have to convert 10 joules into erg. So how many erg? Like you have N1 U1 is equal to N2 U2. This is the formula. So what is N1? N1 is 10. U1 is given joules. N2 we do not know, and U2 we know it's given as erg. So again we'll put the formula. What is N1? 10. Energy, remember work done, I have told you this is M L square T to the power minus 2. This is 111 is equal to N2 we do not know, again M L T to the power minus 2 L square, and this becomes 2 2 2. So for N2 we'll divide it again. So this is M1 by M2 to the power 1. L1 divided by L2 to the power 2. T1 divided by 2 to the power minus. Just a second, class. See, so this is how we'll write. Now N2, we have to write all the SI and CGS system. So mass 1 kg by 1 gram. L1, 1 meter by 100 centimeter, but this time we, 1 meter by 1 centimeter. 1 meter by 1 centimeter to the power 2. And 1 seconds by 1 seconds to the power minus 2. This will again be cancelled. So see, 10 into, this is 1000 kg, 1000 grams divided by 1 gram. Multiply to 1 meter is equal to 100 centimeters divided by 1 centimeters to the power 2. Centimeter got cancelled, gram got cancelled. So what do we have? We have 10 into 10 to the power 3 into, see, this is 100, but we'll write it as 100 into 100, 100 square. That is 10 to the power 4. So this becomes 10 to the power 8. So 10 joules is equal to 10 to the power 8 erg, or you can say 1 joule is equal to 10 to the power 7 erg. But according to the question, this is our answer. Write it down quickly. See class, the next question says convert power of 60 joules per minute into a system in which mass is 100 gram, length is in 10 millimeters and time is in meters. Means power is equal to 60 joules per minute. You have to convert, let's convert this. So this becomes 60 joules by 60 seconds. That is 1 joule per second. Let's have it in the same SI unit. Is this clear? We have just converted power into joules per second. Fine, this is the last portion of your dimensional analysis. Then we'll start with calculus, differentiation and integration we'll be starting with. Now see, this says that, see, usually in our original system, M1, L1, T1, which is present, we have the first mass as 1 kg, we have the length as 1 meter, we have the time as 1 second. Now in our new unit, M1, M2, L2, T2. This is 100 grams. Length is 10 millimeters and time is in 1 minute. So this is now the conversion. These are the values of M1 and M2 which you have to follow. See again, N1 U1 is equal to N2 U2. N1 is 1. U2, this is joules per second. N2 we have to calculate. This is the new system. And U2 is this new system of units which is given. New system of units. Tell me class, this portion, have you understood the question? What is the question saying? Question is basically saying values of M1, L1, T1 are the same, which we have been following. But M2, L2, T2, these are the new values which we have. This is clear to all of you?
Yes, ma'am.
Okay.
Yes, sir.
Now see, let us now just substitute. So joules per second basically means, see, energy is T to the power -2. So when you divide it by time, it will become T to the power -3. So same thing we'll write 1 into M1 L1 square T1 T to the power -3 is equal to new system of units N2, a new value which we have to find out. New system of units M1 MLT 2 2 2. This is square -3. Let us calculate N2. M1 divided by M2, L1 divided by L2 square, and T1 divided by T2 to the power -3. Now let us substitute M1, all these values are normal. These M1 values are normal. So M1 will become 1 kg only, but M2 is given as 100 grams. L1 is given as 1 meters. L2 is given as how much? 10 millimeters. To the power square, and time this is given as, this is 1 seconds divided by 1 minute to the power -3. Now what we have to do, what we have been doing, we have to convert and bring all in the same unit so that this can be cancelled. So 1 kg can be written as 1000 grams. See, when we are converting 1 millimeters, see, 1 meter is equal to 1000 millimeters. Okay, so this we can write it as 1000 divided by 10 millimeters square. 1 seconds, this can be written as 60 seconds to the power minus 3. Let us see, gram got cancelled. 2 zeros are getting cancelled. Millimeter getting cancelled. 1010. Now see. This is 10. This is 100 square. 100 into 100 is 10 to the power 4. This is 60 to the power 3. See, if I bring 60 in the numerator, see, seconds will get cancelled. So 60, when I'll bring this in the numerator, power, which was negative, now it will become positive, 60 to the power 3. So we can write this as 216,000. Just a second, class. Give me a second. Wait. Just wait. So this can be written as 2160 into 10 to the power 5. So final answer is N2 is equal to 2.16 into 10 to the power 10. This is the final answer. Write it down. If you have any doubts in between, let me know. Just one last question we'll do and end this topic. Okay, last question, class. If fundamental unit of force is 100 Newton, velocity is 10 meter per second, and time is 10 seconds, you have to calculate the fundamental unit. See, class, all these last questions which we are doing, no, these are the toughest questions which are possible and which can come. All right, nothing can be more than these questions which we are practicing in the class. So just practice the questions which we are discussing in the class. That is enough for dimensional analysis, at least. Now we'll be starting in the next class, or today itself if we are permitted with time, with differentiation. That requires your practice. Kinematics requires your practice. This also requires your practice, but the questions we are doing in the class are enough. So just pay attention to this. See, this says that force is what? Force is mlt to the power minus 2. This is given as 100 Newton. Fine. Next is velocity. Velocity is lt to the power minus 1. This is given as 10 meter per second. And lastly, time, we have t to the power 1, which is given as 10 seconds. So these are the new units that you have, right? Now, class, tell me if t to the power 1 is 10 to the power 1. So t to the power minus would become t 10 to the power minus 1, right? Now, can I substitute this L into t to the power minus 1? Can I write t to the power minus 1 as 10 to the power minus 1? Look, is equal to 10 meter per second.
Yes, ma'am.
Right? So 10 can go into the denominator because it is negative power is there, is equal to 10, right? So length can become 100 meters. What was the time? Time is clearly, from this only, time is clearly 10 seconds. Now last part is left, mass. Now we know the length, we know the time, we know what is force, we do not know mass. So if such a question comes, no, this is how you have to solve and you'll be able to manage. Can you see, everything is just based upon those 5 quantities which I told you to remember. That's why I have told you. So we have mass with us, which we have to calculate. Length is 100. Time is t to the power minus 2, right? That is 10 to the power minus 2 is equal to how much? This was given 100. So see, clearly this is 100. This 100 gets cancelled. M divided by 100 is 1. Mass is equal to 100 kg. So in our new system of units, mass is 100 kg, length is 100 meter, t is 10 seconds. That's it. This completes with the chapter also. I know I've gone into a little more detail like these questions, but these are the toughest questions which are possible in at least at your level. Fine, class. So that you don't have to refer to, these questions have come in some schools, these questions have come, and this is not a very tough question. If these types of questions come, you will be able to handle them. That's why I'm discussing this. So dimension analysis, basic formula, finding of the variable, that you should know. And with time, when we'll be doing all the chapters, you will automatically remember all the formula. Fine, class. So that would be helpful for you. So write this down. Now we'll start with, first we'll practice differentiation. Then we will complete integration, because these are the core calculus portions which are required for your kinematics. So we'll be discussing these chapters. We'll do it in detail so that even if you do not have maths, wherever, if you have maths and mathematics, wherever, whenever you will be studying it, that doesn't affect our physics. Whatever portion is required in your physics, that much only I'll tell you calculus part. That is very important for you to understand. Anyways, write it down. I'll tell you.